So right now, out in Indiana, Amazon is building this single AI computing site that takes up 1,200 acres.
Which is just massive.
Yeah, it's basically a small city.
Yeah.
And to power this current AI boom, we are looking at facilities that will consume, 20 times the electricity of a normal massive data center.
Right.
So welcome to our deep dive. Today, we're really ripping away the illusion of the weightless cloud. You hear about AI and crypto every single day, right? And usually it's presented to you as pure software.
Just, typing a prompt and magic happens on your screen.
Exactly. You type a prompt, the cursor blinks, and bam, you have an essay.
Yeah.
But today, we are taking you under the hood into the raw physics, the overloaded power grids, and really the sci-fi infrastructure that actually makes these digital worlds possible.
Yeah, it's a completely different landscape when you look at the physical constraints. The data we're analyzing today, it covers everything from energy consumption mapping to bleeding edge photonics hardware.
And some crypto stuff too, right?
Right, the latest on-chain scaling metrics and macro financial flows. And what all of this points to is this massive physical and financial bottleneck.
So we're connecting some pretty wild dots today. We're looking at the huge energy demands of new AI models, the incredibly unexpected pivot of Bitcoin miners.
That one is fascinating.
It really is. Plus, chicks that do math with literal light and the silent upgrades that are finally solving crypto's notoriously terrible user experience.
So let's start with the sheer scale of the AI infrastructure being built right now, because the narrative across the industry is that AI is basically hitting a physical wall.
Right. So just how big is this 1,200-acre site?
Well, think about the footprint of a small city. Amazon's Project Rainier is deploying nearly 500,000 Trinium-2 chips across that site.
500,000 chips.
Yeah, 500,000. And the wild part is that massive undertaking is dedicated exclusively to training just one company's models.
Wait, really? Just one?
Just one. Anthropic's Claude. It's not this, multi-purpose cloud facility. It is a single-purpose compute-dense monolith.
A small city built just to teach one software program how to think. I mean, that really puts the energy consumption into perspective.
It does.
Because the numbers coming out of the International Energy Agency are just staggering. They're projecting that the largest AI data centers currently under construction, they're going to demand 20 times the power of a standard 100,000 household data center.
20 times.
Yeah. But why the sudden, exponential jump? I thought chips were getting more efficient over time.
Well, the chips are more efficient, but the software architecture has fundamentally changed. We're moving from standard language models to reasoning models, like DeepSeek R1.
Right, the newer ones.
Exactly. And these models use a technique called inference timescaling.
Okay, let's unpack inference timescaling for a second. With older models, you ask a question, and it basically runs this hyper-advanced autocomplete to predict the next best word.
Right, just spits it out.
Right, it gives you an answer almost instantly. But reasoning models don't do that.
No, they don't. When you give a reasoning model a complex prompt, it doesn't just give you an answer right away. It pauses.
It thinks about it.
Basically, yeah. It effectively drafts an internal response, checks its own logic, realizes maybe it made a mistake, discards that draft, and tries another path entirely.
Wow.
Yeah, it computes multiple intermediate reasoning steps before it ever shows you a single word.
So it's thinking longer. But the physical consequence of that software design is what's really blowing my mind here. That extra internal drafting practically doubles the electricity consumption per task.
Exactly.
Compared to a standard model, I mean. You are burning twice the energy for a single output. It's like we designed a fleet of supersonic jets, but suddenly realized we just don't have enough refineries to make the jet fuel.
That's a perfect way to put it. The AI industry is desperate for gigawatts of power right now. And that desperation leads directly to an incredibly unlikely savior.
Oh, this is the pivot.
Right. They need high-density power immediately, and they need it connected to the grid yesterday.
Which brings us to the crypto mining industry, specifically Bitcoin miners. Because they are sitting on exactly what the AI industry needs.
They really are.
But they've been mining Bitcoin for a decade. Why are they suddenly so eager to just pivot to AI hosting?
Well, it comes down to the unit economics of mining, which fundamentally shifted during the April 2024 Bitcoin halving.
Right, halving.
Yeah, that event mechanically cut the block rewards, the newly minted Bitcoin given to miners for securing the network, from 6.25 down to 3.125 Bitcoin per block.
So a 50% pay cut.
Exactly. Overnight, the revenue for the exact same amount of work was cut in half, which severely squeezed their profit margins.
And just to clarify for you how that business works, miners rely on their hash rate. That is essentially the pure computational horsepower they dedicate to guessing the cryptographic puzzle required to win that block reward.
Right.
To get a high hash rate, you need a warehouse full of ASICs, application-specific integrated circuits. These are highly specialized computer chips built to do exactly one thing, which is mine Bitcoin.
They are totally useless for anything else.
Right. They literally cannot run Microsoft Word, let alone an AI model. So when their margins got squeezed, the AI companies were suddenly standing at their door with giant bags of cash looking for power.
Precisely. The AI companies aren't interested in the ASIC machines at all. They are interested in the infrastructure housing them.
The power access.
Yes. Because a traditional crypto mining setup needs about 5 to 15 kilowatts of power per rack of machines. But an AI cluster running advanced GPUs, that needs anywhere from 50 to over 100 kilowatts of power per rack.
Hold on, though. This is why I have to push back a little bit. You can't just toss a delicate, multi-million-dollar AI server into a dusty Texas warehouse that used to house a bunch of noisy Bitcoin ASICs.
That's very true.
Right, because AI requires pristine environments, super fast fiber optics, and intense cooling. So is this a realistic pivot, or is this just a story mining companies are spinning to pump their stock prices?
It's a fair question.
Because Wall Street is valuing these companies based on their megawatts and power contracts now, not their hash rates. Are they just buying a narrative?
That's really the million-dollar question. The reality is that this pivot is highly capital-intensive. Converting these sites requires massive CapEx.
Like how much?
Well, you have to strip the facility down to the studs. You have to install direct-to-chip liquid cooling systems because standard air conditioning simply cannot handle a 100-kilowatt rack. You need heavy-duty switchgears and enterprise-grade networking fabric.
So if it's practically a teardown, why even bother? Why wouldn't Amazon or Microsoft just build their own brand new data centers from scratch?
Because of the grid interconnection waitlist.
Oh, the bureaucracy.
Exactly. In many jurisdictions, waiting for a utility company to approve a new site, upgrade the local transmission lines, and install massive transformers, that can take up to 10 years.
10 years.
And 10 years in the AI race is an absolute eternity. The crypto miners already waited in that line years ago. They possess the most valuable assets in tech right now.
Which are?
Energized substations, vast tracts of land, and active interconnection queue rights.
So they essentially skipped the line.
They completely skipped it. And they offer incredible grid flexibility. In Texas, for example, miners are participating in demand response programs on the ECOT grid.
Right, I've seen this.
Because they control massive energy loads, they literally get paid by the grid to shut down their machines when consumer demand peaks, like during a summer heat wave.
But AI data centers can't just turn off, right?
No, they can't. But a hybrid facility can power down its mining side to keep the grid stable while the AI side keeps running uninterrupted. Skipping a decade-long waitlist makes the massive capex of retrofitting these facilities highly lucrative.
Okay, so we find the power, we retrofit the data centers, we install liquid cooling. But looking at the technical specs we're reviewing, it shows that even if we solve the facility bottleneck, we're hitting another physical wall inside the computers themselves.
The chips are choking.
Yeah. Moving all this data electronically between the chips creates way too much heat and traffic. We are reaching the absolute physical limits of pushing electrons through copper wires.
We really are. Copper inherently has resistance, and when you push massive amounts of data through it, that resistance generates heat.
Lots of heat.
Right. So to solve the heat and bandwidth limits of AI, the industry is fundamentally changing the medium of data transmission itself. They are replacing electricity with light.
Photonics. I mean, this sounds like pure science fiction. We are basically ripping out the congested, overheating dirt roads inside the computer and replacing them with fiber optic superhighways.
It's incredible.
The data from Lightmatter, this company pioneering this space alongside Qualcomm, is just mind-blowing. They achieve a record-breaking 1.6 terabits per second per fiber using their co-packaged optics chiplet.
And they achieved that using a 16-wavelength DWDM architecture.
Explain that for us.
To put that in perspective, they are sending 16 different colors of laser light down a single fiber simultaneously. Yeah, that offers 8 times the bandwidth density of existing electronic solutions. So they are drastically reducing the physical space needed for cables while simultaneously cutting power consumption.
But moving the data with light is really only half the battle. On the actual computing side, the specs on the ADPT system show something even crazier.
Yes, ADPT is fascinating.
It's an electrophotonic accelerator. Instead of using traditional electronic logic gates to do the massive matrix math required for neural networks, it uses Mach-Zehnder interferometers, or MZIs, to do the math with light.
Literally computing at the speed of light.
But how does that actually work? How do you do math with a laser beam?
Okay, think of it like dropping two pebbles into a pond. When the pebbles hit the water, they create ripples, right?
Yeah, sure.
And when those ripples crash into each other, they create an interference pattern. In some places, the waves amplify, and in others, they completely cancel each other out.
Okay, I can picture that.
Well, an MZI does this with light. It splits a beam of light, shifts the phase of one beam, and recombines them. By carefully controlling the light, that resulting interference pattern literally becomes the answer to a complex mathematical equation.
That is wild. And because it's light, there's practically no heat and no electrical resistance. ADPT achieves 5.73 times higher throughput per watt than traditional electronic systems.
But there is a bottleneck here, and it requires a very delicate hybrid design.
What's the catch?
We can do the math with light, but we do not have photonic memory yet. We can't just store data in a laser beam. We still rely on electronics RAM, the traditional silicon-based memory chips you'd find in your laptop, to actually hold the data.
Ah, so the system has to translate the light back into electronics to store the answer, and then back into light to do the next math problem.
Exactly, and that means the slower digital memory components risk bottlenecking the light speed processing of the photonic core. It's a massive engineering challenge.
Okay, so let's step back for a second. We are building literal sci-fi hardware. We are retrofitting old Bitcoin mines to house liquid-cooled servers that use lasers to compute intermediate reasoning steps for AI.
It sounds crazy when you say it all at once.
It really does.
Yeah.
But running these models is insanely expensive for the businesses actually trying to use them. How do we keep the software side from just bankrupting companies?
And that brings us to AI FinOps, or financial operations. The hardware is incredible, but if an enterprise deploys large language models without optimizing how they are used, it can inflate their operational costs by 30 to 70%.
Because of tokens.
Right. Token consumption is the biggest cost driver. Every word you send in and every word the model generates costs a fraction of a cent. At scale, that burns millions of dollars.
So enterprises have to get really smart about how they route traffic. They're using a strategy called model routing.
How does that work in practice?
So if an employee asks a simple question, like, summarize this short email, the system automatically routes that query to a cheap, lightweight model. But if the CEO asks a complex predictive data analysis question, it routes it to a heavy-duty, expensive model like a GPT-4 class system.
That makes total sense. They're also heavily utilizing ARGRI retrieval augmented generation.
Oh yeah, ARGRI is huge right now.
It is. Because instead of feeding a model a massive, expensive context window covering a company's entire history every single time a question is asked, ARGRI searches the company's internal database first.
It just finds what it needs.
Right. It grabs just the relevant paragraphs and hands only that specific data to the AI. You drastically reduce the number of tokens you are paying for.
But my favorite trick here is semantic caching. Let's say 10 different employees ask the AI slightly different versions of the same question, like, what are the new HR policies? And can you summarize the updated HR handbook?
They mean the exact same thing.
Exactly. Semantic caching recognizes that the meaning of the questions is identical. Instead of paying the AI model to generate the same answer 10 times, the system just serves up the cached answer from the very first time it was asked.
Which saves a ton.
Yeah, it can save up to 40% on inference costs.
It's brilliant optimization, but we really have to acknowledge a classic economic principle at play here, which is the Jevons paradox.
Right.
As a technology becomes more efficient and cheaper to use, whether it's computing with light or optimizing tokens with semantic caching, we don't actually spend less money overall. We just find ways to consume exponentially more of it.
Because it's cheaper, we suddenly start using AI for things we never would have considered before. Efficiency breeds greater demand.
Exactly. And that very same dynamic, the urgent need to optimize costs and improve user experience to handle exponential demand, is playing out right now in the crypto ecosystem too.
While the miners pivoted to AI infrastructure, the software side of crypto has been quietly undergoing this massive scaling upgrade.
So let's talk about that scaling, because the data from Dune Analytics is fascinating. The Ethereum mainnet, the base layer of the network, now only processes about 15% of transactions in its ecosystem.
Only 15%.
Yeah. The Layer 2 network's L2s like Base, Polygon, and Arbitrum are handling the other 85%.
To understand why, you really have to look at the cost difference. Because in March 2024, Ethereum implemented the Denkin upgrade, which introduced something called blobs.
Right, EIP 4844.
Yeah. And without getting too lost in the cryptography here, blobs allowed L2 networks to post their transaction data back to the main Ethereum network much more efficiently.
Yeah.
It essentially dropped L2 settlement costs to near zero.
So if the L1, the main Ethereum network, is like the Federal Reserve doing the final heavy, expensive settlement of all the accounts.
The L2s are like the Visa network where we buy our daily coffees for fractions of a penny.
That's a great analogy. And because of that upgrade, the base network operated at a staggering 98.3% profit margin recently.
And when transactions cost fractions of a penny, you can finally fix the usability of the network. Because the real game changer for crypto's user experience is a standard called ERC 4337.
Better known as account abstraction.
Account abstraction, I mean, it sounds like a dense accounting term, but it effectively fixes everything people hate about crypto. Think about a traditional crypto wallet. It's basically a physical key to a vault.
Right, your seed phrase.
Yeah, and if you lose the key, your money is gone forever. There's no customer support to call. And if you want to move money, you have to pay a network fee called gas in that specific network's native token. It's incredibly rigid.
Which is a massive friction point for normal users. Account abstraction turns your wallet from a rigid key into a programmable bank manager. You can give the smart contract manager specific rules and instructions.
For example, it enables gas sponsorship. Because the wallet is programmable, an application can instruct the wallet to just route the transaction fees to the app developer.
So the user pays nothing.
Right. The user doesn't even know a fee was paid. It happens seamlessly in the background, just like using a normal website where you don't pay for the server costs.
It also enables social recovery. Instead of writing down a 24-word seed phrase on a piece of paper, you can program the wallet so that if you lose access, a combination of trusted guardians can restore it.
Like what kind of guardians?
Like a hardware device you own, an email address, and maybe a trusted friend. They can verify your identity and restore access. You can even log in with Face ID or passkeys.
It's the missing link that makes interacting with the blockchain actually feel like using a standard iOS app.
Yes. But there is a deeper layer here that brings everything we've talked about today full circle. The documentation from Kobo highlights that account abstraction is crucial for the future of AI.
AI agents, right.
Exactly. They've developed an agentic wallet. Because these wallets are programmable, you can give an autonomous AI agent its own bank account using automated session keys.
This is where all these technologies completely converge. You can give an AI agent a specific budget, set an expiration date on its permissions, and just let it loose.
Right.
The AI can go out, negotiate server time, execute trades, or pay for data sets on its own without a human having to manually click approve on every single transaction.
But here's the blind spot in all of this. We can build autonomous AI agents with their own bank accounts, we can do math with lasers, and we can run these frictionless blockchains.
But none of it matters if the real-world economy pulls the rug out from under them.
That is the macro reality check. These digital innovations are incredibly advanced, but they're still heavily tethered to the physical world and traditional financial markets.
The market outlook data highlights that assets like Bitcoin are increasingly driven by institutional flows. We saw spot ETFs, like BlackRock's IBIT, pull in massive billion-dollar weekly inflows.
Which fundamentally alters the supply and demand dynamics.
Because those ETF issuers actually have to buy and hold the underlying asset.
Yeah.
But despite that institutional integration, these remain high beta macro assets.
And high beta just means they are highly sensitive to broader economic swings. Think of it as an amplifier. If the broader market sneezes, these assets catch a cold. If the market runs, they sprint.
It's a reminder that these markets are heavily exposed to global events. When we see rising geopolitical tensions in the Middle East causing oil prices to spike or lingering fears about inflation, the data shows a massive pullback from these risk-on assets.
Regardless of how good the underlying tech is.
Exactly. Recently, we saw heavy liquidation-driven selling across the crypto market. Roughly $661 million was wiped out in just one weekend as Bitcoin fell back into the mid-$70,000 range.
When inflation fears rise or oil spikes due to geopolitical conflict, institutional investors de-risk. They pull capital out of highly volatile tech and crypto sectors and move it to safer assets.
It's the ultimate irony, really. We have light-speed photonic chips, autonomous AI agents executing trades, and ultra-efficient L2 networks running at 98% profit margins.
Yeah.
But the market still drops because the price of a barrel of oil went up.
It perfectly illustrates the tension we started with today. The digital world is never truly detached from the physical one.
No, it's not.
The constraints of our power grids, the cost of retrofitting warehouses, and the geopolitics of energy production directly impact the frontier of artificial intelligence and digital finance.
So let's bring this all together. We went deep today, looking at the hidden physical and software transformations required to sustain this current tech boom. We explored the massive, city-sized energy hunger of reasoning models that is driving Bitcoin miners to basically tear down their facilities and pivot to liquid-cooled AI hosting.
We saw the absolute limits of electronics being shattered by electrophotonic chips doing math with light waves.
And on the software side, from enterprise AI caching to account abstraction turning crypto wallets into programmable bank managers, we are seeing the maturation necessary to make these technologies usable at a global scale.
It is a profound period of infrastructure building happening just beneath the interfaces you use every day.
Which leaves us with the final thought for you to mull over. We talked about those agentic wallets. Think about this. If AI agents can now use account abstraction to trade autonomously on ultra-cheap Layer-2 networks.
Oh, this is a crazy thought.
Right. And they are powered by AI models running on electrophotonic chips, which are physically located inside retrofitted Bitcoin mines. Are we rapidly building a completely closed-loop machine economy?
An economy where machines negotiate with machines at the speed of light?
Exactly. And humans are no longer the active participants, but just the spectators.
It's a fascinating prospect. The foundation is absolutely being laid for machines to become independent economic actors.
And it all relies on that very heavy, very physical infrastructure holding up our weightless cloud. Keep exploring these intersections because the future isn't just in the software, it's in the wires, the light, and the grid. Thanks for joining us on this deep dive. We'll see you next time.